LightRing is a wearable device for two-dimensional pointing and gesture input. LightRing can track the coordinates of a fingertip on any surface using only an infrared proximity sensor and a one-axis gyroscope. The proximity sensor measures the distance between the ring and the middle segment of the instrumented finger. The gyroscope measures the rotation of the finger. To operate the device, the user rests the wrist on any surface and moves the fingertip left and right by rotating the wrist, and up and down by flexing the finger. To calibrate the system before first use, the user defines the range of motion that feels comfortable by tracing a circle on the table. The calibration software records the sensor readings of this motion for a few seconds and determines the mapping from the sensor output to the screen coordinates. The horizontal dimension corresponds to the finger orientation over time, computed by integrating the gyroscope readings. The vertical dimension shows the flexion of the finger over time. Now the system knows how to map sensor readings to screen coordinates for this user. Once the system is calibrated, the hand can be placed anywhere on the surface, and it can be used just like a mouse or touchpad to draw shapes or to point at targets on the screen. This not only works on surfaces of any material, but it also works in any orientation in space. The following example illustrates why the interaction works regardless of orientation. The system keeps track of the direction in space that corresponds to the neutral wrist orientation, or simply up. As the user moves the hand outside of the current interaction range, here to the left, the system internally drags the neutral wrist orientation along with the user's motion. Now, as soon as the user moves the hand back in the opposite direction, the red cursor follows right with him. This means that the internal up direction has followed the user's hand motion and now points in this direction. It is due to this mechanism that the interaction can be performed anywhere in space. In particular, this also means that the user can take the ring off and put it back on and simply continue using the system. Our assumption that more flexion moves the fingertip down is violated if too much pressure is applied, so that the finger snaps back and forth like this. Also, the method fails if the finger is fully extended and the fingertip is moved with the first joint alone. Finally, while working on this project, we discovered by coincidence that many users operate an ordinary mouse in a way that is consistent with how LightRing operates. Please note that this mouse is not functional. To conclude, we found that our input technique is not only effective, but easy to learn and use, and we hope it will inspire future innovations in the field of wearable computing.